Hey guys, so we only have one set of notes this week. It's gonna have quite a bit, so feel free to like pause it and then come back throughout the week and stuff like that. But basically we're gonna be doing solids of revolution, and so it's gonna be volume. Okay, so we're gonna look at volume. The last 2 weeks we've looked at area. Using integration to find area, and so this week we're going to look at using integration to find the volume of objects. Okay, so I'm just going to read the slide. So it says solids of revolution. That's going to be our title. Our EQ is basically like, how do I use the antiderivative to find the volume of 3D shapes. Okay, sorry, I forgot to write it. Okay, so here, how can we use calculus to find the volume of interesting 3D shapes, such as a Grecian urn? Okay, so if you look at this, we're going to look how we can take like real life objects and kind of place them on a graph, right? So, if I can switch over here. There we go. So, like if you took this and you took this curve, so it says by rotating this two-dimensional region around the x-axis. So if I had this curve, y equals 2 plus sine of x, and I took that flat piece of space and I rotated it all the way around the x-axis, it would generate this, over here in red, this three-dimensional shape. And that shape looks a lot like the Grecian urn in the last slide right there. So see how it's kind of turned sideways? So we're going to look at how you can have these different objects that you can kind of create by taking a two-dimensional region and then rotating it around the x-axis. We're actually going to also take and rotate a region around the y-axis and see that same thing as well. Okay, so we're going to kind of combine them today. So these notes would usually, I would break them up into at least 2 days. So feel free to like go through like half of it, one of the methods, and then like pause and come back and do the other method. But you are going to want to watch both before you attempt the homework. Okay. So, oh, there you go. That was me, how I was trying to do like this. I forgot there's totally an animation of it for you. So, starts with that two-dimensional space and then takes it and rotates it around the x-axis, creating that. And then we look by doing the integral, which we'll do in just a second. It's taking the whole volume of that whole thing. Okay. Okay. So disk method. We're going to look at what's called a disk method and a washer method. Okay. So a disk method is when you take your region and you rotate it around the x-axis. Rotate around the x-axis. It's a solid figure, right? So see how this is a solid circle all the way around. So solid, that's when we use the disk method. So to find the volume of the solid, we can calculate the area of each disk and then add them all up, okay? So in here, we rotated it, right? So it created this circle, all right? So the area of each disk is area equals pi r squared. It's a circle, okay? And then we would need the radius, right? So the radius is the y value of the function, right? So all the way, follow my little pointer here. I think it's like a little light up thing on the other end when you guys see it. So it takes this as my function, right? And so if this is the function and it's going all the way around from the x-axis to the function, that's the radius. And so whatever the y value is at that point, at that x value, that's your radius. So we take for the radius and we plug in f of x. All right? And so then, let me move my little face up here. Pretend I'm like walking around the room, you know, when I move my face. So here's your calculus. To find the volume, we integrate. So we're going to take the volume equals pi as a constant. So that's why I can put it outside the integral. Okay, that's that constant multiplier rule that we learned a long time ago. and we go from a to b of my function squared with respect to x, because it went around the x-axis. So in this one, you just have to square it. That's the only thing that's different, okay? So, well, and multiplied by pi. So it's just like the area. We took the area from a to b, right, when we did the areas the last 2 weeks. We go a to b, and the integral is the area under the curve. And so if it's solid, you just take that area, and we need to kind of plug it into that pi r squared. So you multiply it by pi, and you'll square it. Those are the only two differences. All right. Once we simplify it, it'll look exactly the same. So I talked a lot, and I felt like I confused it. Hopefully with my examples, we cleared up a little bit. All right. Sorry, I'm trying to click here. There we go. So for our first example, this was actually probably the... This has been what I've been least looking forward to, because I want to try to show you how to draw your sketches. And yeah, doing that with this little little pen is a little difficult for my life, but we'll see what we can do. Okay, so example 1, using the disk method. Find the volume of the solid of revolution generated by revolving the region around the x-axis. So if I look at my function, y equals 4 minus x squared, that's this parabola right here. Okay, and then I'm looking at the x-axis, the y-axis, and then this is my shaded region, right? The last 2 weeks of homework, you should have had a graph like this. You should have drawn your graph out and shaded the area, okay? So, so this week, you're going to need to take those already area regions that you have, and you're going to need to draw this solid of revolution created by that area revolved around the x-axis, okay? So here's going to be my little attempt to show you here. So you have your graph, and it's like this, right? So that's what's already drawn right there. And so what you do is, to make a three-dimensional shape, you're going to like reflect it. So what you see above the x-axis, if you're rotating around the x-axis, you reflect it. Do your best, okay? And then I lightly do this usually with like a pencil. I'm going to create these little like as if it was coming around. Okay? And then I would like lightly with a pencil, like wispy, like wisps. I would kind of create these ovals representative of it going three-dimensional. Okay? So, if I do say so myself, that looks pretty fabulous for being with a drawn with a mouse and not being able to create any like lightness to it to give it that effect of actually going around. But see, so this is computer generated, obviously, and then it looks close, right? Like, it doesn't look too bad. So yeah, that's how you do it. Okay? So anyways, there is that. And then we need to find the volume. So we're going to do volume based on the last slide equals pi from A to B. So we're looking at the x's, right? So this is with respect to the x-axis. So my A is 0 and my B is 2 of my function 4 minus x squared with respect to x. Okay, so volume, your area function, if you were to have had this on your worksheet, your area function would have just been from 0 to 2 of 4 minus x squared with respect to x. But now since we're doing the volume, we're going to multiply by this pi, and we're going to square the function to give that the areas of the circles within it. Okay? So when doing this, you want to simplify this first one. Okay, so hopefully you have that binomial expansion memorized by now. So a squared is 16 Minus 2 times 4 is 8x squared, always positive, x to the 4th, right? From a to b, 0 to 2, and then dx, and my pi on the outside. Okay, so you can do that. You can do that by hand. However, I highly encourage you to really use that Math 9 function on your calculator. So again, if you do not know, so first of all, if you press Math and then 9, and it already pops up like with little boxes for you to plug in, perfect. If when it comes in, it says F and then INT, okay? So if it's at F and then INT, and then a parentheses, all right? What you write is the function. So you could do, if you did this first one without simplifying first, you could just do parentheses 4 minus x squared, okay? Then you got to put a comma. You put your a, which is 0. You put your b, which is 2. Comma, crap, I can't remember if the x is first or the x is second. Let me look at a text that I gave to somebody. Hold on, sorry, let me pause. All right, I looked it up. Erase, erase. Okay, you're going to have to do the function, comma, x, comma, a, which in our case is 0, b, and then close it. Okay, so that's how you would use Math 9 when it has that like FINT. If you're lucky, you'll get the one where it literally like just pops up with boxes already. Like that, a box, and then a little D box. If you're lucky, your calculator will let you do that. If not, the other one's not too bad once you know how to do it. Okay. I do not have this. I was not prepared. I should have had my answers already set. But anyways, so you plug that in. All right, so I used Desmos. Actually, you guys should totally just use Desmos now that I think about it. That way you don't have to deal with this crazy shenanigans. So if you use Desmos, you could just plug in the integral, or you either write integral or you find the little integral symbol, and then you just get to plug them in, and it's awesome sauce. So I got about 17.1. Okay? So that's that. Pi, and then taking the function, squaring it. All right. So let's look at it if we had it with respect to the y-axis. Same graph, right? Y equals 4 minus x squared. And so that's when I rotated around the x-axis. But if I were to take that same function and rotate it around the y-axis, it spins that way. So it creates this, like, I don't know, it kind of looks like a hamper to me. Like, I don't know, a hamper wouldn't be able to stand on that little point, but it creates that different look, right? It's not the same, so it's not going to have the same volume. Fun fact. So, oops, sorry. So we're going to take and we are going to set up our integral, and this time we're finding the volume around the y-axis. So since our function is given to us as y equals 4 minus x squared, we're going to have a little bit more work to do for this one, okay?
Okay, so this is where I left off. A whole day has gone by, actually. So anyways, while I was sleeping, I actually like freaked out on, it's not going backwards, this problem. So I did not multiply by pi. So 17.1 is not actually the correct answer. So I'm going to take 17.1 and multiply by, I'm just going to multiply by 3.14 since it's on my little phone calculator. And I'm coming back to it. So I'm going to erase. I'm not going to erase. We'll do blue. And we need to multiply this by 3.14. Or by pi, I should say. And so it's about 53.7. Sorry about that. That is actually a super common error that I see. And it was really weird that I literally woke up thinking that this morning. Okay. So yeah, so don't forget to multiply by pi because it's pi r squared, right? Okay, so example 2, the disk method. Still doing disk method. When you take this region and you rotate it around the y-axis, it gives it that basket shape, like I already said. Here's your little handmade drawing. So if your region looked like that, you would reflect it over the y-axis. You kind of give some wispy, like, bring those curves in, and then whatever direction it rotated, you kind of wing it some little ovals. And if it was done in pencil, it would look a lot more like this red shape. Okay. All right. So, we're going to do our pi r squared, right? So the volume equals pi times the integral from, we're going on the y-axis, right? We went rotated on the y-axis. So we care about the y's range. So it goes from 0 to 4. And our function is going to need to be with respect to y, right? So radius squared. And it has to be with respect to y. So that should give you a hint when you go to plug this function in. If you left it like this, it's an x. And so you're like, oh, wait, I need it to be a y, right? Okay, so I need to take this equation and solve it for x so that I have y's in it. Okay, so minus 4 from both sides. And that would equal negative x squared, right? So then divide by negative, so that's positive, positive, negative, and then square root. Okay, and so you would get plus or minus square root of negative y plus 4 equals x. And the fun fact is that since we're going to square it, that little plus or minus really doesn't matter. So it's going to be square root of negative y plus 4. Okay, and then remember it's pi, my radius is my function, and then squared. Okay, so then this one, you could even just save yourself what you're plugging into your calculator, because that square root and the square, they cancel. So you can just do of negative y plus 4 with respect to y. If you're using your normal calculator, you can just put, you can replace those with x's and it'll be fine. If you do just x and then dx, you'll get the same answer. I'm going to use Desmos. So I'm going to go integral from, actually I'm going to put the pi in front of it this time so I don't forget. So I have pi from 0 to 4 of, in Desmos, you make sure you put the parentheses around your function, okay? So negative y plus 4, oops, oh no, how do I delete? Oh, there it is. negative y plus 4, close parentheses, dy. Okay, and Desmos tells me that that is about 25.1. Okay, I don't know if you could see it. Let's see. So that's kind of what I used for Desmos on my phone. So that's exciting. Okay. Here's some practice problems. Practicing the disk method around the x-axis and around the y-axis, just one for the y. And with the y one, with number 4, you do have to make sure you take this equation and get it to x equals blah 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 with a y in it, because it's going to be with respect to y. Okay, so I'm going to send you guys answers of this soon. I'm really trying to catch up on, I've had a lot of late work turned in, not just you guys, but my financial algebra class. So I'm really trying to get caught up on all this grading and stuff. So it's on my to-do list. Actually, it's not. Let me put it on my to-do list. Answer keys. Okay, so that you can get some practice, and then I will send you the answers and the work and all that stuff, just like I used to, okay? All right, so we have now the washer method. So this is the other way. So you have the disk method and then the washer method. So a washer is literally like this little metal thing, and it's like a ring, and you put it so that like you put it between two surfaces, so that when you're like screwing in a big screw or bolt or whatever, that metal doesn't hit the, say, wood or toilet. They're on the toilet. They're on my toilet anyways. Stuff like that. Okay. And so what'll happen is, the way you get this is, where's my little pointer? Get out of the pen. So this is my region that I'm going to revolve. So notice this little super slow thing. I'm revolving it around the x-axis. There's going to be a hole, right? There's this hole between my area and the region that I'm revolving it around. Okay. And so when we find the volume, we need to take out that, gap. All right. So if you look at the bottom down here, this red is kind of representative of the region that's being revolved around. And when I do disk method, I would get a solid all the way through, right? But I need to take out that gap of space. Okay. So the washer method is just like the disk method, but, oh, here's a fun little larger picture. We'll wait while it slowly goes around. So it's taking that little purple region, it's revolving it all the way around. And so it still has volume, right? It's thick all the way around, but there's this hole inside that you gotta take care of. All right, and one more, boom, done. Cute, huh? Okay, so with the disk method, it's the same thing, but just like when we found the area between two curves and we took the top minus the bottom, right? It's the same thing, but now you're doing the whole pi r squared thing. And so you're just doing pi r squared still, but you got to do the top function squared minus the bottom function squared. Okay. So that's what's different. So when there's a hole in the middle, think I got to subtract out that volume. I have to take out the volume of that hole, right? So you're going to take, and you're going to do your pi r squared. Where's my little, there we go. but you're doing it for the top one first, and then you're going to subtract the volume of what's under that lower function to have that create that hole. Okay, so this is disk method. Washer method. I don't know why. It looks like more of a disk to me. So this is washer method. And again, we use this when there is a hole. Okay. And this is what I would be teaching on like a second day of notes. So if you're like done right now, that's cool. Take a day, go practice those practice problems if you haven't done so already. And then come back to this like a day later, to let your brain kind of rest a little. That's totally fine. Okay. But yeah, so let's get into an example for it, for those of us that don't want to go on, or just when you're ready to go on. Cool. Okay. So, yep. The washer method, the y-axis. So if I were to take this region and revolve it around the y-axis, it would create a hole, right? So here's going to be my little sketch. So you have this region. So when you sketch it, right, you reflect it over, and then I would still like, oh, sorry, my dogs. Sorry about that. Had to pause because they do not like cats, and it's just stupid. So anyways, and then when you do this one, it's a little weird. So you just kind of go around it. You can stay on the outer one. And it obviously does not look as awesome as the other ones. Maybe that's what it's missing. I don't know. But basically, so imagine like, since this is straight, when it's revolved around, it would create like basically a cylinder. So it would look like a can. And then like as if your can had like a thick edge, like, or it had like a bowl cut out of it instead of being the full can hole. Anyways, okay, so x equal to 1 is my outer region, and then this parabola y equals x squared is my inner region, right? So we're gonna do volume equals pi. So anytime we have volume, we're putting pi. Since it's the y-axis, we care about the lowest and the highest. So it's going from 0 to 1 on the y's. Okay. And then my outer function is the 1. So I go 1 squared minus my inner function squared. Now this is with respect to y, right? So if I were to just put y equal to x squared in there, that's not right. Since it's with respect to y, I have to solve for the x. So I would square root, and so x equals plus or minus y, plus or minus square root of y. And so since it's going to get squared anyways, the plus or minus doesn't matter. So square root of y goes in there. Okay, you could plug that in just like that into the calculator. Just remember, on Desmos, it does want you to have like parentheses around the whole function. Or if you wanted to simplify it a little bit first, you could do that. So pi from 0 to 1 of, and then 1 squared is just 1, and then minus the square root of y squared is just y dy. Okay, so I'm going to use my phone calculator on Desmos, And I'm going to do that. So pi from 0 to 1 of just 1, oops, let me put my parentheses for Desmos, 1 minus y, close parentheses, and then dy. Okay, and so this would be approximately 1.570. Okay, and then that would be cubic units because it's volume. But yeah, so pi and then r squared, but when you have a whole, you got to subtract out that volume. So you do your outer r squared minus your inner r squared. If it's on the x-axis, it's the upper minus the lower. Okay, I think I have one more example. Okay, so a manufacturer drills a hole through the center of a metal sphere of a radius of 5 inches. The hole has a radius of 3 inches. Find the volume of the resulting metal ring. Looks like a little bead to me. So for this one, we're going to revolve it around the x-axis. So it's going to be with respect to x. Okay. My outer function is the top half of a circle, right? So a circle is, and it's centered at 0, 0. So the circle would be x squared plus y squared equals my r squared, right? And so my r squared is 25 because it's got a radius of 5. So since it's with respect to x, I'm going to solve for y so that my function has the x's in it. So y squared equals 25 minus x squared, square root, and then see how it's only the top half of the circle? So it's only the positive. So it would be plus or minus, right? Since we put the square root. But because of that, because we can only see the top one, we only care about the positive side. So y equals positive square root of 25 minus x squared. So that is my upper function, this one right here. And then my lower function is a horizontal line at 3. So this line is y equals 3. Okay, and so now I would set up my volume function. So v equals pi from, and then now again we're going on the x-axis. So you go and you care about your from furthest left to furthest right. So from -5 to 5 of my outer function squared 25 minus x squared, outer function squared minus my inner function squared. And then this is all with respect to x. Okay, so again, you could simplify this before putting it into your calculator. So right here, the square root and the square cancel. That's my favorite when that happens. So here I have 25 minus x squared, and then minus 3 squared is 9. So notice it's not -3 squared, right? So it's minus 3 squared. And so that 3 squared, that's the 9, and it still needs the minus. And we could even do 25 minus 9, which is 16. So 16 minus x squared. This is with respect to x. And pi from -5 to 5. Okay, so I'm going to put that in Desmos. Where did my Desmos go? So we are going from, oh no, my integral went away. Oh no, I'm a mess. Okay. Hold on. My integral went away. I'm so sad. There we go. Functions, miscellaneous integral. All right, so I'm putting my pi on the outside. I'm going from -5 to 5. My function, I'm going to go parentheses, 16 minus x squared, close my parentheses, and dx. Okay, and I get approximately 240.86. Okay. All right. I feel like that's it. Let's double check. Oh, cool. Yeah, here's my little summed up slide for you. So it has the disk method versus the washer method. So when you have a solid region between the function and the axis that it's being revolved around, you would use just pi integral function squared, versus when there's like this gap between it, there's this hole, then you need to make sure you're subtracting out the volume of that hole. So pi integral of your outer function minus your inner function. So if you use outer and inner, that works whether it's with respect to x or y. So you use the furthest one first minus the closer one. If it's on the y-axis, or yeah, when you're looking at upper, lower, above, outer, inner, or outer, inner. Okay. We are not going to do, I'm going to show you just a couple, like another slide, just to kind of show you something, but it's not going to do, I'm going to come back to this one and end on this one. So, I just want to let you know that if we were in class, we would go a little bit further and we would revolve around different lines. So you don't have to revolve around only the x-axis and the y-axis. You could take a function and revolve it around like this, y equals -1 or x equals 1. And so I just wanted to let you know that that's like a thing. But we're not gonna worry about that just because I don't want to do too much for this last week of notes. Okay, so hit me up, text me, I'll remind. Maybe I'll schedule a couple Zooms. I'll probably schedule one on Friday, just because I want to make sure you guys are good to go with this stuff. And what do you call it? And then I'm going to be posting your project. So your guys' stuff has to be done by May 15th, which is next Friday. So I'm going to be posting your project this week so that you have more time than just a few days next week. So I'm going to post it as soon as I can this week. It is on my to-do list already. And I'm going to get it up as soon as I can for you guys, okay? And then, yeah, so have a great day. Love you guys. Miss you. Can't wait to see you. Bye.